Hi, my name is Krish Ramanandi and my ID number is 24DCS107. So today my topic is digital electronics in data centers and cloud computing. So I will present about it. And if we see ahead, then digital electronics in data centers. First of all, we see for data centers powering the modern world. Data centers are the backbone of the digital age. They process and store vast amount of data. Digital electronics are essential for computation, storage, and communication within these centers. So this is saying that data centers are backbone of the digital age, and they process and store the large amount of data. And digital electronics is a very useful, or you can say essential, for computation, storage, and communication with these centers. So in this presentation, we will explore about key components, power challenges, cooling solution, and future trends. So all these are important topics about digital electronics in data centers. We will cover all of them now. Next, core digital components, servers and networking. So there are two types. First is we see servers, then network equipments. So servers are the workhorse of data centers. You can say workshop. It is a similar kind of that. They perform computation and run application. High performance CPUs, high capacity memory, and fast storage solution are essential. So these servers have high performance of CPU, high capacity of memory, and they run application through it. Okay, so all the application are running in this workhorse, or you can say workshops. Next, networking equipment. So networking equipment enables communication within and outside the data center. High speed switches, routers, and network interface cards are critical for data transfer. So we use high speed switches, routers, and cards for data transfer, and networking equipment enables communication within and outside the data center. So these two are the core digital components. Next, power distribution, efficiency, and redundancy. So there are three types: PDUS, UPS, and redundant power system. So PDUS distribute power to servers and equipment. Intelligent PDUS monitor power consumption and provide remote control. So it means that the distribution of power is controlled by the PDUs, and the AI integrator, or you can say intelligent PDUs, monitor, or you can say provide remote control. Then UPS, unitary power supply. So UPS system ensures continuous operation during power outages. Battery based and flywheel UPS offer backup power. So battery based and flywheel UPS offer backup power. So then next, redundant power systems. So redundant power systems provide backup power sources, dual power supplies, and multiple UPS units enhance reliability. Okay, so these three are power distribution. Then next, if we add that cooling system, so there are major three types of air cooling, indoor cooling, and liquid cooling. So we will see what type of cooling and which is best for system. So first is air cooling, traditional method using fans and air conditioners. Hot as well, cold as well, configuration separates air stream. So air cooling is a very old method, and in that we use a fan for cooling the system. Second is something you can say mid-level, in-row cooling. Cooling unit placed directly within server racks provide targeted cooling. So it means that the cooling unit are placed directly on the components. So it will cool directly it and get in touch of it. Last is liquid cooling. It is based and it is modern, more efficient than air cooling, especially for high density deployments. Direct to chip and immerse cooling are used. So you will among see in some reels and YouTube shorts that the systems are submerged in some kind of liquid, or they are like water, but they are not actual water. They are some kind of liquid which will cool the system. So it is the best technique to cool the system, and it is very efficient and more efficient than air cooling. Next, then power efficiency matrices, PDE and DCI. So PUE and DCIE. So PUE, power usage effectiveness. So PUE is the ratio of total facility power to IT equipment power. And lower PUE indicates their higher efficiency. So PUE is equal to PUE. What is PUE? Then PU is ratio of total facility power. The total facility power divided by IT equipment power. This is PU, and as decrease the PUE, the efficiency will be higher. Next is DCIE, data center infrastructure efficiency. So DCIE is the inverse of PUE and expressed as percentage. Higher DCIE indicates higher efficiency. So as it is inverse of PUE, when increase the ratio, and it will increase the higher efficiency. So it is IT power to IT equipment power upon total facility power. This is DCIE. Okay. Next is energy storage, batteries and alternatives. So there are three types: lithium-ion batteries, flywheel energy storage, and hydrogen fuel cells. So lithium-ion batteries, common energy storage solution for UPS system with high energy density and long lifespan. So lithium-ion battery are we use in remote and in general use. Lithium-ion battery we can say it is a general we can use it in some experiment. We also use that. So it has a long lifespan and high energy density. Second is flywheel energy store. So we see in PUS that flywheel energy store provides the backup power. So kinetic energy storage with high efficiency for short term power backup. So we for that use flywheel energy storage. And last is hydrogen fuel cell. So generating electrical and oxygen provide source. So these are some energy storage. Next is advanced cooling technologies from nanofluids to AI. So first is AI optimization, second is two-phase cooling, and last is nanofluids. So these three are advanced cooling technologies. Next is data center design, modularity and edge computing. So modular data centers deploy prefabricated self-contained units. They offer scalability and reduce deployment time. And next is edge computing, process data closer to the source. These reduce latency and improve performance. So when the computing process data closer to source, whenever it is the computing process data is closer to source, then it will improve the performance, because these two things are very close to each other. They are not far from each other. So the data transfer is very fast, and it reduces latency and improves performance. Okay, then future trends: quantum computing and new neuromorphic chips. Quantum computing and neuromorphic chips. So quantum computing utilize quantum mechanism for faster computation. This has the potential for breakthrough in various fields. And neuromorphic chips mimic the human brain for energy efficient AI. They offer low power consumption. We seen that Nvidia has launched its new chip, and Google has launched a chip which is you can say very small size, and it is a quantum computer. So the quantum computer are a new future of the this IT industry, and you can say digital electronics industry. And in all computer service, and the quantum computing is a very useful. These big techs like Google, Nvidia has its own quantum computer, which are going to use for some users data and for all this stuff. Next, neuromorphic chip. So neuromorphic chip mimic the human brain for energy. They offer low power consumption. So you can say some of the things which are costing low power. So this is this kind of neuromorphic chip. Next is conclusion: the future of digital electronics in data centers. Critical role: digital electronics are critical for data centers operation and evolution. Key challenges: power efficiency and cooling are key driving innovations. And future trends: quantum computing and neuromorphic chip revolutionize data processing. So in future, as we seen that quantum computer and neuromorphic chip are the future trends, and they will be definitely perform very well. And the digital electronics is a very critical for data centers. So this is all stuff. This stuff is about digital electronics in data centers. Now we see about digital electronics powering cloud computing. So Cloud computing's foundation lies in digital electronics. This presentation explores the relationship, highlighting efficiency, speed, and scalability. We will look at the unseen foundation of the digital world. So now we will talk about digital electronics in cloud computing. So cloud computing's foundation is lies between the digital array. So you can say that the digital electronics is controlling the cloud computing. So fundamentals of digital electronics. So transistors, logic gates, integrated circuits. So transistor, basic building blocks like MOSFET and essential. They are the foundation upon which all digital circuits are built. Logic gates and or not NAND nor perform Boolean operations. Gates are the basic building blocks of complex operations. So these all gates you will study or you studied in the 12th science or you will also study in college. These all gates are very useful to build a Boolean operation and they are building blocks of a complex operation or you can say a complex circuit. Integrated circuits, ICs, they are very useful. ICs combine multiple components on a single chip. That's why they are very useful. They allow smaller and faster electronic designs. Next, digital electronics in data centers. So as you can see in the image, these are some data centers. We seen it in particular we see it in data centers, but here are also we will see something that server architecture, HPC, power efficiency. So CPUs, GPUs, memory, and networking are key. These power cloud computing operations. HPC specialized hardware like FPGAs and ASICs, you can say ASICs are utilized. These devices are specialized to enhance performance. So it means that FPGAs and ASICs are the devices which are specialized or you can say specially work to enhance the performance and power efficiency. So it saves the power and it consumes it has a low latency. So this is all about power efficiency. Next is cloud infrastructure and hardware acceleration. So hardware acceleration, FPGAs, GPUs, ASICs are optimized for specific tasks. These devices can massively improve performance. So these three devices, FPGAs, GPUs, and ASICs are specially designed. As I said, they are specially designed to build or you can say work on something. And these devices have massively improved performance. FPGAs, so reconfigurable hardware enables customized computing. They offer flexibility for specialized computation. So it gives the user a speciality that the user can design that how it can compute and how it can work. GPUs. So GPUs, you know that GPUs they are in laptops like RTX 3060, RTX 4050. These are all are GPUs, and GPUs massively parallel for AI and machine learning applications. GPUs are now essential for modern AI. So for if you have there are something that GPU and chip. If your laptop has a lower you can say lower standard chip, then it will be you can say okay, but for AI something you want to build something AI powered tools. So you need your computer or your system need GPUs, high power GPUs for that because all the you can say all the work has been done by this GPU. That's why it is very important. Then networking and data transmission, high-speed interconnects, Ethernet, InfiniBand, fiber enable faster data transfer. This providing high bandwidth. So these three Ethernet are very common. We use in our computer and we connect it with our CPU. Okay, so these all provide high power bandwidth. That's why the internet speed in computer is faster than the internet speed in laptop because the computer is working with the Ethernet. Okay, then network switches and routers. These efficiently route data packets within data centers. They optimize data center network traffic. So these switches and routers are like a traffic police. They will optimize the network traffic. Okay, data compression, reducing data size, speed of the transmission. So data compression, we are compressing the data, so its size will compress and the transmission, or it will speed up because it will compressing and it is now very light and very small. Next, storage systems and data management. Solid state drive. Oh, it is a very common SSDs. You know that. Then RAID, data optimization. So SSDs, fast, reliable storage for cloud applications, is essential. SSDs improve responsiveness. So SSD are very common. All the laptop computer has its own SSD, and these are very fast, reliable, and you can store your data in SSDs. Then RAID, data redundancy, provides fault tolerance for a critical system. RAID is crucial for availability. So for availability, RAID is very useful and crucial. Data optimization, as I said, we will optimize our data. Yeah, we will optimization. It means deduplication and compression improves storage. So we will compress the data, so it will improve the storage, and it will costing our loss. So these tools minimize storage use. So as we use storage minimal, and we will minimize the use of storage, so it will cost us our low. Next, future trends and innovations. Quantum computing, neuromorphic chip, we discussed in data centers. New are novel materials and 3D integration. So this advancement will influence the cloud industry, and you can see all these things. 3D integration will increase density and performance, and so it means that these all are our future trends, and we will use them. 3D integration will increase density and performance, so it will increase the performance of the system. Okay, AI is everywhere now. AI is everywhere, and neuromorphic chip, novel materials. These are future trends about that. And last is conclusion. Digital electronics, the engine of cloud. It is a very heavy word, engine of cloud. Cloud computing thrives on digital electronics advancement. Continuous innovation boosts performance and scalability. Future trends promise even more powerful cloud services. Stay informed about the latest developments. So, conclusion is that the cloud computing is rely on digital electronics, and the cloud computing thrives on digital electronics advancement. It boosts the performance and scalability. Okay, so this is all about my presentation. Thank you.